Hi there. Okay, so today we are dealing with a math problem. It involves solid shapes. Uh, excuse me. And what I'm going to try and show you is how to calculate the area. So first of all, let me reduce this and read you the question. The question says, determine the exact total surface area of the hemisphere attached to the cylinder. From top to bottom, the cylinder is 30 centimeters and the radius of the hemisphere is 4 centimeters. So what I have done is I have done something. It's pretty crude. It's just made out of Play-Doh, but it should be something that you can see and kind of get a visual. So I have a cylinder. Okay, so like I said, it's very crude. There's the flat base. There's another flat base, and then it has a circular side. All right, and then I have a hemisphere which is like that. So it has like a dome shape. It has a flat bottom, and then so it kind of looks like that, right? And the shape that the question is talking about more or less resolves to this shape. So you have a cylinder and then you have a hemisphere sitting on top of it. Now, because like I said, it's a crude drawing or crude object, in the question, the diameter of or the radius of the cylinder and the radius of the hemisphere are supposed to be equal. Okay, so having said that and having showed you this, I'm going to revert back to the diagram and we will do some calculation. Okay, so here we go. All right. Uh, so a few things before we start off. First of all, the question does not state whether the cylinder is solid or hollow, and that will make a difference to the final surface area. So that's something we have to keep in mind. And what we'll do is we'll calculate both, so whichever applies. And then the second thing is that the hemisphere itself, that is a very simple calculation for the surface of area of the curved surface. Remember that as I was showing you in this diagram, in this model, this surface of the cylinder and the bottom of the uh, hemisphere, they attach together. So that surface does not count. So one of the surfaces of the cylinder and the bottom of the hemisphere are not relevant. All we need is the curved surface of the hemisphere and the curved sides of the cylinder. And then if it's solid, then we will also need the bottom of this cylinder. If it's hollow, then of course it doesn't have a bottom because it's like a pipe, and so that won't be needed. So that's the difference. Okay. And then the third thing is that irrespective of the cylinder being solid or hollow, the end at which the hemisphere is attached will not count because that end of the cylinder is covered by the hemisphere and that at the bottom. So I've just explained that visually, so I hope that makes sense. Otherwise, you can always read it here. And if you have any questions at the end, always remember to uh, send me a message and I can uh, get back to you. All right, so let's start with the circumference or with the circle or the cylinder. Like I said, the hemisphere part is simple. We'll apply a formula, we'll solve it, and be done with it. Now, for the cylinder, I want to think of the cylinder as a pipe. So let's say, for example, if it was hollow, like in the first part. So what we're saying here is this, and let me see if I can get back to it, the bigger, like that. Okay, so if I were to take a sheet of paper and roll it up like this, okay, so let me show you. So if you look at it like this, it's a cylinder, it's round, and it has hollow ends. Do you see that? So this is a cylinder. It has curved sides and it has hollow ends. This is a hollow cylinder. Now, to find the surface area, what you have to think of or what you have to imagine is that you can actually open this cylinder up like this. If you open it up, it becomes a rectangle, right? So you see how it's a cylinder when it's rolled up like this, and it becomes a rectangle when you open it like this. So the rectangle that it makes has a height that is the side, right? And then the top or this end of the rectangle actually curves and makes a circle. So if we can find the circumference of the circle, we can find the length of the rectangle. The width is already given, and so then it's a simple process of multiplying this by this, and that's your area of the rectangle, which is the same thing as the area, the curved area of the cylinder. Okay, so back to the calculation here. So the circumference of the circle, which will be the end of the cylinder, if you like, is is given by 2 pi r. I'm sure you're familiar with that formula. So 2 pi r, we apply that formula and we find the circumference of the cylinder, which is 25.131328, and that would be a centimeter square. I'm sorry, I didn't do that before. Square on that. That will look right. Anyway, it's a square. I mean, I don't have to worry about it right now, but this is a centimeter square. So that's the area of the circumference only. Now, once you have the area of the circumference, what you need to do is multiply that by the height and get the area of the curved surface of the cylinder. So you get 30 times 25.1328, and the total. Oh, you know what? I am so sorry. This is not a square. This is just centimeters. Yeah, that is just the length of the circumference. That is not the area. So area is 30 times 25.1328, and it comes out to so many centimeters square. This is the area of the curved surface of the cylinder. Okay, then the next part is to calculate the area of the curved surface of the hemisphere, which is essentially, like I've said before, it is half of the full sphere. And the area of the sphere is 4 pi r squared. Once we divide by 2, we should get the area of the hemisphere. And putting those numbers into the formula 4 from the formula, pi for 3.1416 from the formula, and then that 16 is the square of 4, which is the radius of the hemisphere. And then the whole thing is divided by 2 because it's a hemisphere and the formula is for the full sphere. And that works out to 100.5312 centimeters square. So now all you have to do is add these two together and you get the surface area of that shape uh, with if the cylinder is hollow, so that we're not counting the bottom. If the cylinder is not hollow, then we proceed to find the area of the circle, because if it's not hollow, then the bottom of the cylinder is a circle, and the area of the circle is pi r square. So we plug those values into the formula. Same 3.1416 for pi, 4 for r, and another 4 for r because we have r square, and that gives you the area of the bottom of the cylinder. So if you add all three together, you have the surface area of that shape so that it's a solid. But if you add just the top two, you get the area of the shape provided the cylinder is hollow. Okay, so I hope that answers some of the questions. And I also want to let you know that this information, the question came from the Wisent website. Whoever the student uh, saw some answers and then they wanted further clarification, and I decided that I'm going to do a video so I can explain it better, and I hope that it helps other students also. uh, so visit my YouTube channel anytime you want. I have some solved problems on physics, and then whenever I see an interesting problem, I solve it and I put it up on the website. Okay then, so that's all for now. This is Mr. A signing off.